Okay, so in this clip we're going to look at the second 40 marks on the WJEC Intermediate Tier November 17 Paper 1. So the first question is to do with recognizing quadrilaterals and the properties of them. So look at the following descriptions of special quadrilateral shapes. So it will correct a name for each one. So we can see here in each of these we've got the same list of shapes. So what I would do is draw a little sketch of each of those shapes first of all and then match back their properties. So I know that a kite is a shape that looks like that, and its diagonals do that. A rhombus is a square where all the sides are the same length but it's been pushed over. A trapezium has one pair of parallel sides. A square, all equal sides, and a rectangle two pairs of parallel sides, two pairs of equal sides. Okay, so those are my shapes. A, its diagonals intersect at 90 degrees. Only one diagonal is a line of symmetry. So as far as diagonals are concerned, square will intersect at 90 degrees and a kite will intersect at 90 degrees. But whereas with a square they're both symmetrical along those diagonals, with a kite it's only on one of those diagonals. So the kite is the first one. Only one pair of sides are parallel. Well, hopefully you can see that that is the trapezium. All four sides are equal, so it's one of the rhombus or square. Its diagonals are not equal in length. You can see there, if you draw the diagonals there, that diagonal is a lot shorter than that diagonal, so it's the rhombus. So again, with a question like that, don't guess unless you really have to, but if it helps you to do a little bit of extra work, do the extra work. Complete the table below. Draw the graph of y equals 2x squared minus 5 for values of x between -2 and 3. Use the graph paper below. Choose a suitable scale for the y-axis. So as you can see, they've put a scale on the horizontal, the x-axis, but they haven't put one on the y. So if we look at the values that we're given there, we can see that the largest y value is 13. So 13 has to fit on the graph. So if we were to go 2, 4, 6, 8, it wouldn't fit on the graph. If we went 5, 10, 15, 20, it would. So that's the scale that I'm going to choose. We now need to work out what each little square counts for, and if this is the scale we're using, we're going 0 to 5 in 10 jumps. So 5 divided by 10 is half, so each little square in that direction is 0.5. What I suggest you do then, before we work out what that missing value is to plot the points you've got, because that will help you work out what number will be reasonable when you come there, in case you make a mistake. So when you're plotting, first one is -2 and 3. 1, 2, 3. Put a cross so that when you draw the curve through it, it's clear. The examiner can clearly see where that point is plotted. We don't know what -1 is yet. We know that 0 is -5, 1 is -3, 2 is 3, and 3 is 13. Now, quadratic curves, if the x squared term is positive, which an intermediate here almost always will be, you're expecting the curve to do that. If the x squared was negative, it would be an upside down curve, but it's always a smooth curve with one sort of minimum point. So because of that, I'm looking and I'm going to be expecting the value of x value of -1 to be sort of around about -2, -3. So I'm going to be mindful of that when I'm working out this value. I replace the x with -1. So y will be 2, and then if you look at the x is like two brackets the wrong way around. So if you think that in order to put a number in there, I'm going to explode those, and when I explode them, they become the other way around. So when I'm replacing the x with a number, it becomes a bracket like that. Squared, take away 5. We work out the squaring in the bracket first, and then it's joined by a times 2. So that's going to be 2 times. Now when you square a negative number, 1 times 1 is 1, minus times a minus, negative times a negative, signs are the same, the answer becomes positive. So that becomes +1. Take away 5, 2 ones are 2, take away 5, 2 take away 5, -3. Which is what we were anticipating through the path of that curve. So all my points are clearly marked. When you go to draw your curve, you don't draw it with a ruler, you draw it freehand, and your wrist is a natural pivot. So what you do is you turn your graph around so that your wrist, your hand, is on the inside of the curve, and it makes it much easier to draw a smooth curve through your points. So that's what they're looking for, with the lines extending beyond the 2 points, the 2 extreme points in your list. If you want to practice those, go to the website, topic list, and graphs of quadratics, etc. Part B. Sketch above can represent only one of the equations given below. Circle this equation. Well, just like in order to work out those y values, we put in x values and work out the corresponding y. I can see there that when x is 0, this curve is above, it's going to have a positive value. So if I put x of 0 into each of these, for the first one, 0 squared is 0, so that would cross at 0, 0, which would be there. So it isn't that one. If I put x is 0 into this one, that's going to be 0 squared is 0, y would be -3. It would be down there, so it's not that one. Y equals minus x squared would be 0. 0 squared is 0, it's neither plus nor minus, so that would be back there, so it's not that one. Y equals x squared plus 3. Y equals 3, y is a positive 3 value, so it could well be that one. And then the final one, again, if we put 3 times 0 equals 0, so it's not that one. So it has to be that one, because that's the only one when you put x as 0 on, which is where it'll be on this axis, that works out with a sensible outcome. Okay, then we've got some transformations. First one is a rotation. When you rotate, it has to tell you how you're turning, 90 degrees, which direction you're turning, anti-clockwise, and where you're pivoting from, -2, 3. You're expected or allowed to use tracing paper for this, so make sure you ask for some. The point minus 2, 3 is negative 2 up 3. So that's where we're going to be sticking our pen in the tracing paper. So what you then do is trace your shape and then mark on it a little arrow going up your page. And now what you want to do is anticipate which way that arrow is going to point if it's being turned through 90 degrees, so a quarter of a turn anti-clockwise in that direction. So hopefully you'll see, or you'll recognize that that will be pointing in a horizontal direction to the left. So we then hold our tracing paper down on the point minus 2, 3 and turn it until that arrow is pointing in the direction we'd anticipated, which is there. So that's where your shape is going to end up. So then just copy it over. So that's your rotation 90 degrees anti-clockwise about the point minus 2, 3. Enlarge triangle B by a scale factor of 1/2 using 0, 0 as the centre of enlargement. So a scale factor of 1/2 is going to shrink the size of that triangle. It's going to become half the size that it is. So this side, which is 4, will become 2, and this side, which is 6, will become 3. Now in order to work out where its position following that reduction or enlargement, it's telling us to use 0, 0 as the centre of enlargement. So what you then have to do is to take each corner, each vertex of the triangle, and work out how far across and down, how many squares across and down it is from the centre to that corner. So we see there it's 1, 2, 3, 4, 5, 6, 7, 8 across and 2 down. So we're going to half 8 across and 2 down, which will be 4 across and 1 down. So that corner is going to end up there. And then we know that rather than being 6, it's going to be 3, and rather than 4, it's going to be 2. Because the scale factor is 1/2. So half of 8 is, half of 6 is 3, half of 4 is 2. So you do locate one vertex from the centre of enlargement to the original and half it to find out the position of that corresponding vertex in the reduction, and then half everything from there. Okay, so the next question's on circle theorems. If you haven't revised this isn't going to mean anything to you. On my website there is an introduction to this that I do, so if you look in the topics for circle theorems, you'll see an introduction there for the ones that you're expected to know at the intermediate tier. So the two that you're expected to recognize from this is that you have tangents to the circle, and here you have 2 radii coming from the center to the tangent. When that happens, the tangent and the radius are at 90 degrees to each other. And then the second fact that you need to know is that the distance from the point to each tangent will be equal in length, turning that triangle PQR into an isosceles triangle. And what we want to work out is the size of angle OQR. So we need to work out what that little angle there is, which is inside an isosceles triangle, because if that's a radius too. But I don't think we need to know that for this particular question. You must indicate any angles you calculate, and you must give a reason for each stage of your working. So in order to get the 5 marks here, you have to put in words what angle fact you're using. So the angle fact that we're using here is that PQO equals 90 degrees. Angle between tangent and radius is right angle. Okay, so angle between tangent and radius is RT, right angle. So that means PQO is 90 degrees. Now, because this is an isosceles triangle, I can work out what PQR is. So triangle PQR is isosceles. Lines between a point and tangent to circle are the same length. So point, tangent to circle, that distance and that distance are going to be the same. So PQR is an isosceles. So PQR, angle PQR, will be 180 less 30 to get the sum of these two, which is 150, divided by 2, because there are two of them, which is 75 degrees. So I now know that I got a 90 degree there, and to that part of it there is 75. So OQR is the difference between, oh sorry, didn't see that was off the screen. So show you again, we've worked out now that that angle, the bottom of the isosceles, is 75 degrees. This part is 90 degrees, and what I'm interested in is the difference between the two. So it's the difference between 90 and 75. So angle OQR is 90 less 75, which is 15 degrees. Now, let me just have a look at the mark scheme. If you can do that but not cope with the explanations, you will still get 3 out of 5. So there are 2 marks for the you must give a reason for each stage of your working. But if you struggle with that because you can see by looking at it what's happening but can't put it into words, if you got that 15 out, then you would still get 3 out of those 5. Like I said, if angle properties are your thing and you can revise them quite easily, have a look at the circle theorems work on the website. Question 12. Using only a ruler and a pair of compasses, construct is the important word here. It means that they're looking for evidence that you've used the compasses. A perpendicular line from the point P to the line AB. So what they're looking for you to be able to construct is a line that goes through that and cuts at 90 degrees. So the way that you do that, you get your compass and you open it out a reasonable length, stab the point in P and draw. When I say reasonable length, that wasn't reasonable because it didn't go through. I've gone in with a rubber. It's got to go through the line, which that one didn't. So let's try again. Open it out a bit wider so that it goes through. Oh, this is great. That's too wide because it's not cutting the line in 2 places. Third time lucky. Right, there you go. So it's crossing in two places. Now where it's crossing there and there, because it's on part of a circle, anywhere on that circle is an equal distance from P, because it's all at a radius of whatever I've opened it out to be. So what you do then is you move your compass point to where it crosses and draw part of the circle, and over to here and repeat that, and where those two curves cross, if you draw a line through there, it gives you a line which is perpendicular to AB. So that there is going to be 90 degrees. So to get the marks for that, they're looking for this construction, this curve here, and then the two intersecting curves which you draw the line through. Question 13, standard form. Now, whenever I work with standard form without a calculator, I tend to work with powers of 10 as if they were 100 tens in units. So if I have my decimal point there, the first column beyond that would be a unit, then a 10, then 100. So if I unit 10, 100, and I know 100 is 10 squared. And then I can use that. That means 10 is 10 to the power of 1, 10 to the power of 0, 10 cubed, 10 to the 4, 10 to the 5, 10 to the 6, and so on, going that way. And for small numbers, 6, 5, 4, 3, 2, 1, 0, what would be next? Negative 1, minus 2, 3, 4, 5, and so on. So once you've got your list, and you can do this if you don't want to do it or there's no space on the question, then don't forget that at the back you've got a page for additional working. So you can do this on the back. Right, so the first number that we've got is 0.00042. For it to be in standard form, the digit part of it has to be between 1 and 10. So with this question, we need the decimal point. We want that to be written as 4.2 times 10 to the power of something. And if it was here, then I'd be writing 42 times 10 to the negative 5. 42 times 10 to the negative 5 isn't a number between 1 and 10. If I have it here, it's going to be 4.2 times 10 to the negative 4, which is what I'm looking for. With the second part, what you do here is you deal with these separately. So that's a divide. So you're going to be doing 7.2 divided by 2 times 10 to the power of 6 divided by 10 to the power of negative 2. 7.2 divided by 2 is 3.6. And here, what you need to remember are your laws of indices. When you're dividing where the bases are the same, so in this case 10 and 10, when you divide, you subtract the powers. So here, that's going to be 6, take away negative 2. Signs are the same, it becomes a positive, so that's the same as 6 plus 2, which is 10 to the 8. So again, on the website, there's lots of practice to this. It's a fairly new video that I've done on standard form. So we've got 3.6 times 10 to the 8. Calculate the value of 4.7 times 10 to the 5. So let's come back down to my grid. 4.7 times 10 to the 5 will be here. So the 4 is in the 10 to the 5, otherwise it would be 47 times 10 to the 4, and then you would have to fill in the zeros between the 4 7 digits and the decimal point. And from that we're going to subtract 6.2 times 10 to the 4. So the 6 will be in the 10 to the 4 column, 2, 0, 0, 0. And we're going to subtract those. 0, 0, 0. I can't take 2 from 0, so I write it as 60, 10 rather than 70. 2 from 8 is, 2 from 10 is 8, 6 from 6 is 0, 0 from 4, 4, 0, 8, 0, 0. You're then going to give your answer back in standard form. Has to be between 1 and 10, so it's not 408 times 10 to the 3. It's not 40.8 times 10 to the 4. It is 4.08 times 10 to the 5. So as soon as you've put that line of powers in, it makes it a lot more straightforward to deal with. As I said, plenty of practice of that on the topics page, intermediate topics page on Jones' sum. Question 14. A group of students from a school took part in the International Eisteddfod. All of them competed in at least one of the following competitions: singing, dancing or reciting. 2 of them only took part in a dancing competition. 5 of them only took part in a reciting competition. No one took part in both reciting and dancing. 3 took part in singing and dancing, etc., etc. The Venn diagram below shows some of the information above. The universal set E contains all of the pupils, so the universal set is the rectangle. Every one of the pupils has to appear in that list. The way that the circles work is all the students involved in singing will appear within that circle. If they appear in this bit where there's a 0, that is an intersection of the 3 circles, so anybody that was doing all 3 would appear in there. But as it makes clear, there is nobody that took part in all of them. If we're in this intersection here, then those students would be singing and dancing. That 2 there is saying there were 2 students that only danced, and so on. So let's transfer the information that we've got. 2 of them only took part in dancing. That's that 2 there. 5 only took part in reciting. So the only reciting is this part here. So we'll have 5 in there. No one took part in both a reciting and a dancing. So that would be 0 in that intersection. 3 took part in both singing and dancing, which is there. 9 took part in reciting. So if I know that all of that circle has to represent 9, I've already got 5 in. There's only one part of that circle left, which means that has to be a 4, so that the whole circle adds up to 9. And 22 took part in singing, and I've already got 7 appearing, so that means that 7 from 22 is 15 will fit in that circle, or that part of the singing circle. Okay, so that's my Venn diagram. What is the probability that a person chosen at random only took part in a singing competition? So only took part in singing is this region here, which is 15, out of the total number of pupils taking part, which isn't written in the question, so we have to get that by adding up all the numbers in the Venn diagram. So we've got 0, 20, 24, 27, 29 pupils. So the probability of a person only taking part in singing is 15 out of 29. Again, topic list, intermediate, Jones' sums, plenty of practice on Venn diagrams there. Factorize x squared minus 7x minus 18. So again, this is something that if you haven't practiced isn't going to mean anything to you. So factorizing a quadratic expression. The stages you go through are like this. You first of all list the factor pairs of the number only term. So what numbers multiply to give 18? So I have 1 and 18, I have 2 and 9, I have 3 and 6. And that's it. Those are the only factor pairs of 18. And what I then need to do is to look at, with combinations of pluses and minuses, is there any way that these factor pairs can add up to give me negative 7? So it's factor multiples of the number only, and then can I make 7 out of 1 and 18? Well, if they're both positive, I get 19. If that's positive and that's negative, I get 17. If that's positive and that's negative, I get minus 17. And if they're both negative, I get minus 18. So it isn't that one. With 2 and 9, if they're both positive, I get 11. If they're both negative, I get negative 11. If the 9 is positive and the 2 is negative, I get plus 7. But if the 2 is positive and the 9 is negative, I get minus 7. 2 take away 9 is minus 7. So the numbers that I need in this factorization are plus 2 and minus 9. The way that these are then written is as a double pair of brackets, xx, and the two number parts will be the ones that we fixed there. And with this question, it's easy to check whether you're right, because if you can do this, you certainly have practiced multiplying out brackets. So you can just do a little check again down here or on the back page. You have to multiply each number, each term in this bracket by each term in that bracket. So x times x is x squared. Then you do x times negative 9. Then you do this one times that, which is plus 2x. And then this one times that, which is minus 18. Tidy up your x term, minus 9 plus 2, which is what you wanted. So I know I've got those marks. And then the and hence solve means that you can now write this left hand side as that. And again, this is a standard thing to do. So if you revise this, what I'm going to say now is straightforward enough. Anything times 0 is 0. And what I've got here are two brackets multiplied together. So if I can get a value of x, which will make that go to 0, everything when multiplied out will become 0. So if x was negative 2, out of negative 2 plus 2 is 0, that will all go to 0. So either x is negative 2, or we make this bracket go to 0 by putting x as 9, because 9 take away 9 is 0. So the and hence solve is writing down the values of x that will make each bracket go to 0. Question 60. Solve the following simultaneous equations using an algebraic, not graphical method. Again, if you haven't revised this, what I'm about to do won't make any sense at all. If you need to practice, go to Jones' Sums, and there are lots of questions on there on simultaneous equations that I take you through. The important thing to do is to number your equations each time, so it's clear what you're doing. And what you have to do is to multiply these to make either the x terms or the y terms the same. Now, when setting out with simultaneous equations, what we often tell kids is if you multiply the top one by the number in front of the bottom x and the bottom one by the number in front of the top x, then you're making those the same and you'll be able to eliminate them. But often that ends up dealing with large numbers. At intermediate tier, the chances are you're a bit better at maths than a foundation tier student, and you don't have to just repeat that. You can do a little bit of thinking first. Now, what I'm looking for is the lowest common multiple of 4 and 6, which is 12. So in order to make those the same, I only have to make them 12. And to do that, I take equation 1 and multiply it by 3. And you multiply the whole equation by 3. So 4x times 3 is 12x. 3 times 3 is 9. 2 times 3 is 6. And then to turn the second one into 12, I have to multiply it by 2. 6 times 2 is 12. Minus 5 times 2 is minus 10y. And 1 times 2 is 2. If you did them the times 6 times 4, you're still going to end up with the right answer, but you're working with larger numbers. So I've now got two new equations, so I'm going to call those 3 and 4. What we do next is we subtract. We do equation 3 take away equation 4. And when we do that, 12x take away 12x, gone. So we lose one of the unknown letters. Then we've got minus 9y take away negative 10. So we're subtracting a negative number. That's the same as minus 9y plus 10y. We're subtracting minus 9, take away negative 10, take away a negative, minus minus makes a plus, equals 6 take away 2, 4. Minus 9y plus 10y is 1y, equals 4. So we've worked out the value of y is 4. We then have to work out the corresponding value of x. So we can replace y in any one of these 4 equations with the value of 4 to work out x. Usually it's easier to put it in one of the originals, and I'll put it in equation 1. Substitute y in 1. So 4x take away 3, and instead of writing y, I can write 4 equals 2. 4x, 3 4s are 12, equals 2. To get rid of the 12, I have to add 12. If I add 12 to that side, I have to add 12 to the other side as well, giving me 4x equals 14. And then to get the x on its own, I have to divide by 4. I have to divide that by 4 as well. 14 over 4, which is the same as 7 over 2, which is the same as 3.5. So you can leave it as 7 over 2, or you can write it as 3.5, or you can write it as 3.5, it doesn't matter. So we've got two solutions, y is 4 and x is 3.5. As I said, if you haven't practiced that, you won't have a clue what's going on there. You need to go back and practice more. And the final question. A cylinder fits just inside a hollow cube with sides of length m centimeters. So m, it's a cube. The radius of the cylinder is m over 2, or half m. The height of the cylinder is m, so it's touching the cube. The ratio of the volume of the cube to the volume of the cylinder is given by volume of cube colon volume of cylinder equals k colon pi, where k is a number. Find the value of k, you must surely working. Right, well, this is clearly well into the overlap now between the higher tier and the intermediate tier. It's a grade B question, but it looks very complicated and is full of algebra. So let's take it one step at a time. It's a cube of side m, and we're working with volumes. So let's work out what the volume of the cube is. M times m times m. M cubed. Now we work out the volume of the cylinder. Volume of a cylinder is the area of the cross section, which is a circle, so it's pi r squared, where r is m over 2, times the height, which is m. M squared, the radius squared is going to be m squared over 2 squared, which is 4, times m. M squared times m is m cubed, so that becomes pi m cubed over 4. So now to write that as a ratio of volume of cube to volume of cylinder, we get that. We can divide both sides by m cubed. M cubed divided by m cubed is 1. Pi m cubed over 4 divided by m cubed is pi over 4. Now we want to get the pi on its own, so we're now going to multiply by 4 to get pi, and that means we have to multiply this by 4 as well to get 4. So 4 to pi means that k is 4. So that's what you need to do. You're watching this video, or you're watching that question as part of an intermediate tier, so that is a question that difficult to anticipate, and probably one that you're not going to lose any sleep over, given it's the last question on the paper. However, you should be able to make some progress by just writing, well, the volume of the cube I can work out the volume of the cylinder, but I get a little bit lost from there. So that's it. That's the complete November 17 Intermediate Tier Maths Paper 1.